All right, so we're going to be talking 240.87 as per the 2017 version of the National Electrical Code. Now, 240.87 was first introduced in the 2011 version of the NEC. It only impacted circuit breakers without an instantaneous, and those were only those power circuit breakers that didn't have an instantaneous, which is a very small portion of all of the breakers that we make. In the 2014 code, there was a recognition that, hey, it's not quite what we were thinking. We really wanted to expand this beyond those breakers. And so they honed in on 1200 amps as a trigger point. And again, remember, this does not apply to medium voltage breakers because it is in part 7 of 240, Article 240, and 240.1 tells us 1 through 7 only apply to circuit breakers up to 600 volts. And now let's take a look at 240.1. I want to make sure that it did not go. Yep. So 240.1 actually moved to 1,000 volts. And that is a part of the 2014 NEC as well. So 240.1 moved to is at 1,000 volts, so applies up to 1,000 volts. So what did we do in the 17 version? We didn't change anything in regard to the trigger point. Still 1,200 amps. Although there is starting to be a realization that it's not about the size of the overcurrent protective device. It's more about the relationship between arcing current and the clearing time. So you're starting to get this panel going, all right, so it's about arcing current. It's not about the voltage volt current. It's not about the size of the overcurrent device. And if I have an arc reduction technology, how do I know it's going to actually work? So 240.87 is starting to introduce the arcing current discussion. There's still no definition of what arcing current is, yet we introduced a new term in the 2017 code. So the parent text of 240.87 didn't change. The documentation requirements did not change. But the method to reduce clearing time, they added a few items in here. They added the instantaneous of a circuit breaker because they realized that your equipment could have a high enough fault current that the arcing currents are already in the instantaneous region and you don't need an arc reduction technology because your job was to reduce incident energy. And if the arcing current at that equipment is already high enough, then why do I need the arc reduction technology? It's not doing anything for me. I'm buying something and I'm already inherently in the arc reduction mode because my fault currents are high enough. Now, some of that could be said about 230.95 for ground fault protection of equipment as well, because the reason we had 230.95 is because in 1971, we went from ungrounded to grounded systems. We went from 208 to 480 volt systems. We went from an average of a 600 amp service to a 4,000 amp service. Moved the instantaneous over to the right. Now my arcing currents are in the long time region. Boom. I was having problems. So we came out in 1971 with 230.95 to address that. For grounded systems greater than 208 volts, because the fault currents are going to be lower, higher voltage, lower currents, lower arcing currents, and hence GFPE requirement. So, but if my fault currents are high enough, then what do I care about GFPE too? Because a ground fault is going to go 3-phase within 2 cycles, proven by Duncan Jacobs in IEEE documents. So here we are in 240.87 saying, okay, we're going to add an instantaneous trip setting that is less than the available arcing current, or an instantaneous override that is less than the available arcing current. So I have an instantaneous trip setting, which is that adjustable setting. If I set it for whatever amps and it's low enough that it's going to activate on arcing currents, then I'm golden. Or I can have an instantaneous override that's built into the overcurrent protective device, the circuit breaker. Because remember, all molded case circuit breakers and insulated case circuit breakers are going to have an instantaneous. If it's not adjustable, it is an instantaneous override. It will be in there to protect the breaker itself. And if my arcing current is high enough, then that breaker is going to do its job. You can't get it to go any faster. And then we left an approved equivalent means. So the 17 code introduced a new term as arcing current. Now, if you think about IEEE 1584, if you know anything about arc flash calculations, we calculate two different arcing currents. We calculate a maximum arcing current and a minimum arcing current. Your highest incident energy could be the minimum arcing current, not the maximum. But the code doesn't say anything about whether or not you're using the maximum or minimum. So if you're an electrical inspector and the engineer, to get out of this requirement, uses the maximum arcing current because that happens to be in the instantaneous region of the breaker, but the minimum does not, there's nothing in the code that says you can't do that. That becomes an ethical issue for the PE, whoever's putting the stamp on it, because the PE will know if they were going to label that equipment based upon that clearing time, they're going to use the lower arcing current. So if you're getting a PE to do this, they'll probably do it the right way and put an arc reduction technology on it and use the lower arcing current. But arcing current is not defined in the National Electrical Code. Where do we go for that? IEEE 1584. And the other issue that you have introduced right now is that we have no way to calculate a value of arcing current for fault currents greater than 106,000 amps. An equation does not exist. So if I have greater than 106,000 amps, then I don't have a way to meet 24087 to establish that the arcing current is greater than the instantaneous trip. Now I say that if you calculate arcing current at 106,000 amps, and that value is greater than the instantaneous pickup of this breaker, then you know higher fault currents, higher arcing currents, they're all going to be in the instantaneous region. You could go to the bank with that one. But if at 106,000 amps, I am not in the instantaneous region of that circuit breaker, then I can't calculate an arcing current to do that comparison. And what that would tell you is you're going to need one of these methods outside of the instantaneous trip: zone selective interlocking, energy reduction maintenance switch, or differential relaying to address this. They added a couple informational notes. One was the instantaneous trip is a function, okay? And then the other is 1584, the 2012 version, on calculating, because they introduced arcing currents, and they know that IEEE 1584 is the only place where we know how to calculate arcing currents. And 1584 has limitations. And one of those limitations is 106,000 amps. So be mindful of that. Have your strategy ready if you have fault currents greater than 106,000 amps. If the arcing current at 106,000 amps is in your instantaneous region, go away, leave me alone for anything greater. But if at 106,000 amps the arcing current is not in your instantaneous region, which I would find very hard to believe, but if that's the case, then you're going to be using an arc reduction technology, either items 1, 2, 3, or 4. All right. And that's 24087 as part of the 2017 National Electrical Code. Thanks. Hope that helped.